This morning, so as we're listening to the presentations this morning, something Jack said that I want to talk about a little bit is this whole thing about volume, variety, and velocity. And why do I say that? Vertica, also a V, right? So we say volume, variety, and velocity equals Vertica, right? Pretty simple. It's all about the V's. So we walk around like this all day. So I want everybody, this is what we're going to do as we pass in the hallway today, everyone with the V, okay? No, but on all seriousness, those three V's are actually, I mean, they're absolutely critical. But the other one that Jack mentioned this morning is actually more important, and that is value. Because the reality is, and we think about this big data thing, to me, big data is not a technology. To me, big data is an approach, it's a methodology, it's a way of doing business. Because the real key to big data is not the data. The real key to big data is what you do with it. That's the important thing of big data. Because frankly, organizations for years have been storing and collecting data. But what they haven't been able to do is to use it in a way that real time drives value. So that's why we talk about big data analytics in real time. Because the closer to real time you can get, the more effective that analysis of that information is going to be for you to make real time decisions that impact not just your decisioning on go forward business, but also the way, in fact, you interrelate with your customers in the marketplace. So we look back, and as was mentioned this morning, that this big data thing's been around for a while anyway. But I would suggest that big data today is much different than it was 4 or 5 years ago, and that is because about every 7 to 10 years we see in technology, the delivery of technology, this giant, we'll call it a tectonic shift. Let's relate this back to how many remember ASP? Right? Remember how big ASP was back in the 90s? What happened to ASP? Because to me, SaaS is pretty much like ASP. But the difference is the tectonic shift in technology makes SaaS able to be delivered, whereas ASP was just not, it was before its time. The technology was not quite ready yet. So when we think about these tectonic shifts that occur, it's a change in technology that really eliminates inhibitors or barriers to delivery that allows you to change the way you do business. That's what we have gone through now, is this tectonic shift that changes big data from simply big, heavy warehouses collecting information to real-time analytics driving business decisions in real time. That's what we're talking about here. Let's think about today what are some of the big focus areas out there. Mobility, social, right? Social 5 years ago, people looked at social and thought, what are you thinking? Social. Now look at it. We have on tweets, 98,000 plus tweets every 60 seconds. I mean, think about that for a second. That's people all over the globe every 60 seconds sending tweets. We get status updates on Facebook. Right now, I don't update my status. My kids do all the time, and they tell me I ought to so they can keep in touch with me. But the reality is 695,000 status updates every 60 seconds. Social is huge. The other thing that's huge is cloud computing. And then the fourth one I'm going to suggest is this notion of big data and what you do with it. These things are changing the way in which businesses work. And what we see in this wave, who ever heard of a Yoda byte? Okay. How about a Bronto byte? You heard of that one yet? All these things are now being cataloged because the growth of data is leading us there. Because now, from this tectonic shift, technology is to the point at which we can not only collect it in a cost-effective manner, right? But we can also access it, utilize it, and drive value out of it. So when we start thinking about all these data collection elements, one of them is through these sensors, right? And sensors come in all shapes and fashions. HP has several customers that are doing different things with sensors. One of our customers is doing things with what they call Richter sensors. It's really, call it seismic sensors. What they're doing is they're planting sensors in the earth all over the world to take readings and constant readings to determine and predict things. The amazing thing about this is they estimate that when they get this system fully in place, there's going to be over 1 million sensors collecting seismic information. Those million sensors are creating somewhere between 70 and 100 terabytes per day, 25 plus petabytes a year. We're talking one company with one sensor focus. We think about companies like Boeing and airplane engines. Do you know that two airplane engines, so a jet with 2 engines, one trip across the country, that the sensors in those airplane engines generate over 2 terabytes of data in one trip across the country. Now you have thousands of airplane trips every day, and you have how many engines when you start talking about thousands of airplane trips. That's the way sensors are collecting data today. So not only do we have to be able to collect it, but we have to collect it in a cost-effective manner. Because if we're growing at 25 plus petabytes a year, the traditional data warehouse cost structure is unattainable. You can't continue to drive at that level. So you've got to look at it from that perspective. Then we start talking about these sensors getting up to close to 1 trillion sensors by 2030. That's 150 for each one of us. Think about that for a second. In the world, there'll be 150 sensors for one of us that are collecting these kinds of data. Ultimately, we're going to need roughly 1 million times as much storage and processing in order to get through all that data. Just to set the stage on what this is going to. Now this information, this data, comes in different forms, functions. We talked about sensor readings, right? Structured, things that are structured. We talk about, and I'll talk about this later in the discussion, we have a customer, a communications customer, who is collecting network data. Okay, that's typically always structured data, it's elements. Sensors are more structured, but we also have the human language. We were talking this morning with one of you out here, and I won't point that individual out, about video, collecting data elements in video, human things, live or unstructured things. And these things are all developing into billions, and in some cases trillions of transactions that continue to collect this information. Now the question is, what do you do with it? When we start thinking about where we've gone through this tectonic shift, prior to it, we were collecting this data and we were doing backwards analysis. And those backwards analysis would tell you historically what occurred, and often those analysis would take hours, days, weeks to run. As we've gone through the tectonic shift, and we now have technology that can deliver this stuff more rapidly, we can do predictive analytics. We're working right now with a global SI partner in the energy space. Because in the energy space, when you start thinking about energy moving through pipes, right? That's how they transport it. Natural gas goes through pipes. And every natural pipe that's put in the ground to transport these pipes are all rated by the manufacturer of the pipe. And those ratings could be something, and I'll put it in simple forms, that maybe it's 1,000 foot-pounds per second that this pipe could withstand. And over that, with that type of throughput, it will last 30 days before it has to be replaced. Just to set an example. Now, the interesting thing is you've got aftermarket companies that come out and say, hey, we can improve that because we've got this Superman tape that you can wrap around the pipes, and now instead of 1,000 foot-pounds per second, you can jump it up to 2,000 foot-pounds per second. There's only one catch. It's not rated. So you have to determine how long it's going to last before you have a failure. And in energy, if you have a failure, you could be down for weeks fixing the failure that could cost you tens of millions of dollars. But if you have predictive maintenance, you can take it down for a day and have it fixed and up to speed. So they're placing sensors all along these pipes to sense what's going on in the pipe, to predictively determine when maintenance should occur so they can shut down the pipe before it fails, saving tens of millions of dollars a year per pipe. Amazing business. Predictive analysis, that's the kind of stuff that is now that we're now capable of delivering. And then we have things obviously like smart metering and clickstream, and selective marketing, geospatial analysis, and the like. Now, when we think about that, though, we need to think about data, or I want you to think about this concept of a conversation with your data. Imagine that for a second. Historically, we asked a question and we got a response. It was really almost a one-way dialogue. Here's your response. What if you could literally converse with the response such that in near real time you can analytically refine your analytical questions to really get to the driving point that you're trying to discover? So think about that for a second. What would that do for you? It would allow you to create personalized customer experiences much more rapidly. I'm going to talk about a retail customer that we have here in a moment that is doing just that, where their managers in their stores have iPads or some sort of mobile device, and they're getting real-time store analytics as customers are in their store. Real-time analytics about customers, about products that are moving, about inventory, about movement of inventory, all those things. So they can say, hey, in the last 2 hours, this section of our merchandise is moving, that section isn't. Too bad that's at the back of the store, or vice versa. So you flip and move those around.
Just to, as you mentioned that they're actually using facial recognition with cameras, placed also as well as in mannequins, actually recognize customer opportunities.
Absolutely. Absolutely. So it's amazing stuff they're doing with this real-time analytics. Proactive financial strategies. Boy, I would love that. I don't know about you guys, but proactive back to 07, 08, and 09, I'd love to have had some proactive analysis. New product ideas. Now, here's the important thing about this, because we talked again about this tectonic shift. All of this, in my estimation, I'm gonna steal from was it Visa or MasterCard for a second? Whoever I need to give you credit to, it's priceless. All this is priceless. However, what if you could get all this and you could drastically reduce the total cost of ownership of this analytical infrastructure that gives you it from the traditional way of doing business? And when I talk substantially reduced total cost of ownership, just to give you an example, we have a customer who just purchased some of our solution last month. And between now and November, they're going to be moving data off of a traditional system onto ours, doing analytics, and it's going to save them between now and November, $12 million, because they're not going to have to renew the infrastructure of that traditional system. Huge payback. We're talking about total cost of ownership dramatically reduced. So much so that as we went out, and Forrester actually did an analysis, we call this thing, now this morning there was a mention about, again, Jack mentioned ROI, and the traditional wording for ROI is return on investment. We've actually changed that to return on information, because to us, again, big data isn't about storage. Big data is about getting value out of what you store via storing it in a cost-effective manner, accessing it in a very high velocity manner so that you can get real-time or near real-time feedback. So when we think about return on information, we look at it as three primary factors. Factor one is insight. The value of what you're getting out of the information. In other words, I've got the data, I get it, but the insight that I get out of it is part of the value equation. The data itself is not the value equation. Time to value, how quickly can I get that insight? And in this case, as I mentioned a moment ago, converse with that insight, continue to refine that insight so I can get the real value points. And then finally, the total cost is how much the organization would spend to accomplish those things. So Forrester went out and did an analysis with a few of our customers because they wanted to do a 3-year risk-adjusted cost-benefit breakdown of a series of customers who have implemented our technologies. So in the benefits breakdown, now this is a comparison to what they were doing prior to, which was primarily traditional data warehousing. First, the performance and stability increased by 55% over the historical infrastructure. The hardware cost avoidance and scalability improved by 43%. And the maintenance systems administration improved by 2% efficiency just on the maintenance. Now here's the real kicker to me. is the cost breakdown. Out of all their costs now, 60% were internal planning and implementation. 32% was, in this case, Hadoop. It was a database in the back end. And only 8% of their costs were associated with Vertica. And Vertica is the one, in this case, that was actually pulling the data, analyzing the data, rerunning the data, and delivering the time to value. That's where big data pays off. Not in the data, but in what you learn from it, the insights you get that you can actually act upon. So we created this little formula with that in mind, and that is we take volume and variety, how much data, the volume of data, the types of data, structured, unstructured, semi-structured, all the different varieties. We multiply that by the depth of analytics that you get from it, by the number of users, and we call that intelligent information insight. Now, to get a value statement, we divide that by time to value. We call that the value of the data. Again, not just the data, but all of these things considered delivers the value of the data. We then divide that by the traditional costs associated with supporting this, the CapEx, the OpEx, the typical IT costs, total cost. That gives you your return on investment. Because again, data is not about, or the value of data is not about the data, it's about the insight you get out of that data. So the question I often get is, how do you do that? So we're going to look at this from a standpoint of two perspectives. One is, I'm going to talk to you from a Vertica perspective, but I'm also going to talk to you from a broader HP perspective, because Vertica is part of HP, and as such, our value statement has vastly increased. When we talk about specifically about Vertica, Vertica was, from its very inception, designed for the tectonic shift of going from data warehousing to big data. It was designed to accomplish high compression, very, very, very fast speeds, and scalability at low total cost of ownership. That was its design point. So when we start thinking about that, the key element here is industry standard servers. Vertica runs on your industry standard servers. We're not going to require you to put it on a specific type of hardware that is expensive. It can be on commodity stuff. The important thing there is keeping total cost of ownership down. The next aspect of it is having openness so that it has all the connectors to the Hadoop, the R, the ETL tools, the BI tools. Again, to make sure that it's focused on delivering fast analytics. Volume, variety, velocity, value. It's all about delivering value. Now, we sell it as a software, but now with the HP relationship, how many of you know that HP has a hardware business? Anybody? Yeah, obviously facetious. Yeah, it's about a $100 billion a year hardware business. What we've done is we've capitalized on that also, because we do have some customers that want, and some organization will call them appliances. We call them app systems, just because we're different. It's kind of like our acronym is actually only a 2-letter name as opposed to 3 because we're more efficient, right? So HP versus longer names. But as we look at this hardware thing, this app system, what's important about this is we've taken industry acceptable, very fast and valuable but standard hardware, like in this case, the DL380, and we've put our software on it. We've run all the testing, all the optimizations, all the ratings to make sure that we know it, when it's plugged in, it runs in the way it runs and what it delivers. But beyond that, we've built it in a modular fashion so that customers can get one of these, put it in, run on it. When they run out of data space, they add another one. And they can just keep building, and it's a linear build on a modularity perspective. The flexible configuration, these go into your infrastructures. They set up in your networks, whether, whatever protocols have, whatever rack settings you have, these are designed to go into your infrastructure and not require another set of configurations. And then lastly, it's all on the cost-efficient x86 architecture. So we've tried to continue to keep the total cost of ownership down, but deliver on this notion of velocity and value out of big data. I mentioned a moment ago that we have a few customers, and I'll talk about a few of these in a little bit more detail. But here's an example of some of the customers that we have in some of the industries that we have them in. We do business in healthcare. We do business in financial services. We do business in communication, in retail, in online gaming. Quite interesting, some of the early adopters of this concept of big data analytics, real-time analytics, were the online gaming systems, right? Because, and I'm in this context, I'm talking primarily of any of you guys have kids played World of Warcraft, or you may have, whether you want to raise your hand, that's totally up to you. But you got World of Warcraft, you got games like that. You've got Zynga out there as one of our customers that are doing all kinds of games. That's real-time stuff. They're trying to analyze, as people are online, how to feedback analysis and information to them. So we've got customers across the entire spectrum doing different types of use cases throughout. Because ultimately, again, the database, the data is not the value, it's the use case. It's what do you get out of them. So we're doing it on patient records and claims analysis and loyalty analysis and network analysis. All these things, regardless of the variety of the data, whether it's structured, unstructured, semi-structured. And all these things incorporate different types of data elements. So one of the examples that I want to talk about, one of our customers, Blue Cross Blue Shield Association, put in our system, and they did it for a research effort. They wanted to collect data, analyze data for research in real time. I love Doug Porter's quote here. He said, "We started small with one research effort. Results set came back so fast that we thought the query had failed." I mean, to me, that says it all, right? When you are looking at the pre-tectonic shift results, and you're thinking, 8 hours isn't bad. And then all of a sudden you get it in a sub-second, your first question is, it couldn't have really run that query. It didn't do what it was supposed to do, until you look at the results set. And then you go, holy cow. In sub-second, it ran what I needed it to run, the query that I needed to receive. They're doing additional things now with modeling of healthcare costs, chronic illness prevention, detection of claim fraud, so on and so forth. Obviously in the healthcare business with the implementation of Obamacare coming out, there are tremendous needs. So those of you in the healthcare industry, I know inside you're going, holy cow, there's a lot of stuff you need to think about with all the changes in the regulation and the new policies coming out. This can help you do that. Another example is Comcast. Comcast is, and I believe they claim, I've never looked at the data, but they're the nation's largest cable provider. Why is that important? It's important because the way they're using this to monitor their network for their customers. And they're doing it to try and identify, to ensure quality of service and different metrics to make sure. It's interesting in the communication business, and again, we were talking to someone a moment ago, when you start talking about entertainment media, the cost of entertainment media gets pretty big. Really gets big if you cannot maximize or optimize the viewing of it, right? Because if you don't get revenue from it, you still have to pay the royalties to even have the license to market it. And as a result, what they did, one of the things is they're out there analyzing what movies are available and to whom and when and what areas of the country rent what types of movies typically. And then they reset their licensing with, or I should say, they guide their licensing with the studios based on their customer base instead of just based on a gut feel. And they've had tremendous improvement in that. The second thing is, again, analyzing outages. So they run analysis on networks for outages to try and predict in advance when an outage could occur based on different scenarios to ensure that they are helping their customers stay up on their system. They manage the boxes from an update of the boxes perspective, an outdating of the boxes perspective. They're doing all of this thing through, all of this stuff through through our solution set to help them do it. As they said, as Brian said, they didn't even think these kind of things were possible pre this vertical deployment. Retail sales, I mentioned a moment ago, the customer's guess. Again, they're walking around with handheld mobile devices. And in those handheld mobile devices, they're getting real-time information back about activities that are going on in their store right then. Where they used to wait 3 hours for these analysis to run, they're getting them in 1 to 2 minutes now. How many customers, or how many of you would go in a store and stay north of 3 hours that your feedback would even help while you're in the store? I'm a 15-minute shopper. Man, I go in and get what I need and I'm out. That would have no effect on me, but 1 to 2 minutes based on my habits now would have an effect, and they can drive value out of that. The last one I want to talk about now, and I want to preface this, this is not a political statement of any sort, okay? Regardless of your political affiliation. The point is, the Democratic National Convention uses our solution set. Why is that important? They started using it in 2008. They perfected it in 2012. What they did, and there's actually, you can go out here and you can play the playback. We had a webinar with them where they ran through everything the way that they used Vertica. But here are the points to take away. Whether it's an election or whatever it is, the way that you reach people is critical to the outcome. They have limited budget. Well, some would say $100 million is not limited. But in some cases, they would say, we have limited budget. We have to spend our money wisely. Some organizations simply broadcast to a large market via TV. That's worked for years, right? It's worked for years. 2012, that didn't work. What the DNC did was they have Vertica set up in an analytical database, and they were collecting information on all the voting public that they had any connection to whatsoever. They tracked it over the years. They loaded it in, figured out what are hot buttons, what aren't hot buttons. And then their people, they sent out in the competitive states, and they sent them out with handhelds. And these people would actually input where they're going. I'm going to 412 Elm Street. It would come back and tell you, Bob Jones lives there. And oh, by the way, these are Bob Jones' hot issues. You need to talk about these two things, but don't mention that. Because if you mention that, you're going to turn them off. And what they did was they did an analytical set to precisely target. Now, again, politics aside, an amazing usage of capturing the market they were after and influencing the thoughts of that market to get the result they were after. The interesting thing to me as you watch the election the night before, every one of the traditional, and I'm going to say this tectonic shift again, the traditionals that were before the tectonic shift never saw that result coming, right? Every one of them, again, regardless of what side said it's going to be close. These guys changed the game by using the technology that has allowed them past that tectonic shift. The technology that allows them to change the game, and that's what they did. And frankly, that's what I'm going to challenge every one of you in the room is if you want to change the game in your business, it's not about collecting data, it's about what you're going to use the data for and the time to value that you can use it in. Because your competitors, everybody out there is talking about big data, right? Big data, big data, big data. The point is, if you don't act on it, they will. And at some point, whoever gets the output and the analysis first is going to win the game. They're going to get to the end game first. That is exactly what occurred here, irrespective of positions. That's how they changed the game. So again, if you want to see that, you can go to this webinars section, and you can actually see that webinar. So, all that said, the last thing I'm gonna plug here before I turn you over and actually let you take your break and go have some cake is we've got our user conference coming up. Now this we bring prospects, we bring customers, we bring people who are interested in Vertica, people who also are using Vertica. We've got a guest speaker this year, Billy Beane. Any of you guys heard of Billy Beane? You know what Billy Beane's known for? Changing baseball. Why did he change baseball? Because this whole, roster and the amount of money you spend, he changed the game. The Oakland Athletics spent less than most competitive organizations in those days, and they won because he did analysis on individuals. Moneyball. That's like, I'll call that the pre-tectonic shift mindset, is he was able to take the thought and apply it before the technology was even available. Now the technology is available to do what he did with that organization. That's what I challenge all of you in your organizations. Be in this case, Billy Beane, and change the game on your competitor. So with that, thank you, and any questions afterward, we'll be around.